with this, but I will explain the process. So the first thing we're going to do is completing the square is factor out a 3. And actually, in this case, forget that. Actually, never mind. Yeah, why is it equal to 0? Vertex form. All right, so if it's going to be, we don't want to equal to 0. That'd be like solving it. Or maybe you are solving it. I don't know. But if I wanted to write this in the vertex form, I want it to be written in the y. And the reason why that's important is because I'm going to divide everything by 3. When I divide everything by 3, if it was 0, I'd just have a 0 to the left-hand side. And maybe we could do it. Maybe I'll show you. Let's put 1 in the vertex form, and then let's solve 1. Maybe that'll make, I'll do that problem a little bit differently. So this is a 1/3 y, and now this is a x squared plus 6x minus 16/3. Okay, so now another way we complete the square, a little bit different than the way I did it last time, is again we can so what do I do? Yeah. So now what you can do is find the value that we want to create a perfect square trinomial for here. So we're going to take 6 divided by 2 and then square it. Okay, so we have a 1/3 y equals, and then we'll do a x squared. 6 divided by 2 is 3. So that's 6x plus 9. But again, remember, if you're going to add 9 on one side, you're going to have to subtract a 9 on the other side. So we have 16/3 and minus 9. Now, I don't really want to, I do not really want to subtract 16/3 minus 9. So what I'm going to do is I'm going to multiply everything by 3 again. Therefore, that's going to get rid of that. I have a 3. I can simplify this to a x plus 3. Quantity squared, right? That's factor form. The 3 times the 16/3 becomes a negative 16. And then this becomes a negative 27, right? So you're multiplying the 3 times everything. And then therefore you'd have a negative, what, 43? Y equals a 3, x plus 3 squared. And hopefully you guys, math geniuses out there, are confirming that I did that one correct, hopefully. Well, hello. None of these calculus for life sciences, anything like regular classes. I'm not sure, Melanie. Typically, if you're taking a calculus for another class, like if it's calculus for like calculus for business or what, like it's not, it's much more geared to your own class than I'd probably say to calculus. So they teach you some of the fundamentals of the math of the calculus, but majority of stuff is going to be applied calculus. So it's not going to be as much calculus rigor as you would with a regular calculus class, at least from what I can see or what I have seen. Well, thank you, Wyatt. I greatly appreciate it. That is awesome. It's kind of at the end, Charlie. I do appreciate the end question, and I'm sorry I'm not going to be able to get to it, but it is time. I still do got to go back to school, and again, even through the summer, I always like to do at least an hour. But let me go through this, because if I was going to solve this, I do the same process, right? But I divide by 3, and then I have 0 equals x squared plus a 6x minus a 16/3. Now again, I can complete the square here again. So by completing the square, I get a x squared plus 6x plus 9 minus 9 minus a 16/3. Now in this case, actually, yeah, it wouldn't be that fun, because now I'd actually have to x plus 3 quantity squared minus, let's see, I'd have to a negative 27/3 minus 16/3. So 0 equals x plus 3 quantity squared. Why do I keep on writing equals? Minus, that would be a 43/3. Okay, now if I wanted to go ahead and solve, and again, this would work if you set this equal to 0, you get the same answer. But now you can go ahead and solve for here. You'd add the 4/3, take the square root, and then subtract 3. And again, look what happens over here. If I set this equal to 0, you're going to get the exact same answer, right? So I'm not sure what the student wanted, if there was one form or the other. But if you add 43 divided by 3, you're going to get the exact same component we have here. So